Hello guys, how are you doing today? My name is Pawan Malwal and in today's video I'm gonna discuss about the RDD transformations and action. And as if you have seen my previous video about RDD operation, it's a continuation of that. And as we all know that the RDD supports two different kind of operations. Okay, so one is transformation is and another one is the actions. So transformation is nothing but a new data set from an existing data set, right? So transformation, what a transformation does is it will create a new data set, or it will create a new RDD from the existing RDD. For example, if you take a map transformation, so what it does, it passes each data set element. So in a case of file, it will traverse through each and every line of the file, and ultimately it would apply some function whatever we mention in the map. But on the other hand, when it comes to the action, so action is nothing but which perform some kind of operation on your RDDs, and it results, or it generates the results and sends it back to the driver. So for example, you say count, or maybe reduce by a key or something, or maybe you apply some kind of aggregation. So when you perform an action, it gives you the result, but the transformation results you another RDD. So RDD is lazy, or all the transformations are lazy. So that's the reason we say the RDDs are gets evaluated lazily, because every RDD transformation results into another RDD and it doesn't perform any action on it, or not none of the, it doesn't even generate any result out of it. Okay, so what we're gonna do is we'll look into different transformations which we have in RDDs, and we'll try some sample programs with it. Okay, so let's move on to the next slide. So in this I have taken the data from Apache Spark website, where it says the transformation and its meaning. So there are different types of transformation. So what I'll do is I'll take each and every transformation one by one, probably explain you a bit about it, and we'll try out some sample uh, programs with it. Okay, so let's take up map. So map is nothing but transformation which takes a function as a parameter. So what happens is it would return, so meaning of the transformation is it returns a new distributed data set formed by passing each element of the source through a function. Okay, so as I just mentioned that in case of map, what it does, it if you're reading a file or if you're reading a data set, what it does, it suppose in a file you apply a map function, it would traverse through each and every row of the file and apply the function what you have mentioned here. Okay, so let's try some example of it. So let me open my IntelliJ. Okay, so for setting up the IntelliJ to try out your Spark programs or Scala programs, I have created another video. You can have a look at it. So it doesn't take much time to set up this environment, but it's very easy. You can run the Spark in the local mode with the help of Maven project, and you can also go to the Spark UI and check how the how your programs are getting executed in Spark, and you can even have a look into the detail of the Spark program. So we'll do that. Okay, so let's create a sample program for map transformation. So what I'll do is this is my package where I'm gonna create a new Scala class, okay, of object type. So I'll name it as map transformation. Okay, and double click on it, so it would create a new Scala object which is of the map transformation type, right? So let's create the first thing what we do is create a main function here. Okay, so just type def main and press tab, and it will create the structure of your main function, and inside it we are gonna define our code or the logic. So the first thing in any Spark program is to create a Spark context, which is the entry point of your Spark program. So to create a Spark context, we need to have a conf object. Okay, so let's create a conf object. So say val conf equal to new and say Spark conf. Okay, so as this is not imported, so it is giving you, or it is highlighting it in red. Okay, so what we'll do is we'll import the, sometimes I mean it even imports it by default. So what we can do is we can probably type the imported statement, import, and this package is available inside org.apache.spark. Okay, so Spark has your context. Oh, sorry, I mean the conf. Okay, so once you import it, it would turn white. Okay, so now it has taken that. So we are supposed to give some of the configuration along with it. So we are supposed to set the application name. So these are the mandatory parameters. So you just say dot set and it will show you the options selected, and you need to provide the name of the application. So in our case, we would probably say RDD map transformation. So I mean, as this is the first program, I'm just typing it. From next time or the next program, I'll just copy it from my existing code, so it would make it faster. But I just wanted to give you guys a the idea to have some hands-on when you're trying it, and it would make you more comfortable. Okay, so next is setting up your master. So master is nothing but your the mode on which your Spark is going to run. So we say local here. Next thing is you create a Spark context. So we'll say SC. Okay, and it would be new Spark context. Okay, and Spark context takes conf as a parameter. Okay, so here is your Spark context. And next thing what we'll do is we'll just set the log level to error. Why we do this? To just avoid some unnecessary logging. Okay, so when we execute the program here on IntelliJ, you would see a lot of logs are getting printed on your console. So this would minimize that. Okay, it's only for that. So it's not mandatory, but it would just avoid unnecessary logging. Okay, so the next thing is probably just to try out your map operation. What we can do is we can take a file. Okay, what we'll do is we'll read a file. So the example what I was just mentioning, we'll read a file, and then we'll probably the count or the length of every row in the file. Okay, so we'll create a RDD of it. So let's say val, and RDD type is file RDD. So we'll say file RDD. Okay, and how we do it is with the help of Spark context dot, if you say, it will have a text file method. So it takes your input path as the parameter. Okay, so my file is here, so I'll just copy. Okay, so I'm gonna use probably the sales file. Okay, so we'll give this, and we'll use sales 20 records. Okay, fine. So this will read your file, and if you go and click on this and press alt plus sign or alt equal to the plus or the equal to key just beside your backspace, once you click it, it would show you the result. So the result is you will get the RDD of string. So that would be nothing but your row. So every row you will get inside this RDD. Okay, so nothing but your all the lines in your file. So next thing what we are supposed to do is, as I just said, that we need to take the length of each and every file. So for that we can make use of the map transformation. So map transformation, what it does, it would traverse through each and every line. Okay, so let's just type this val and say line length as a variable. Okay, line length equal to, we'll say file, that's our previous RDD. Okay, file RDD dot map. Okay, so the moment you type map, it will create a function and will give the lambda expression here. So for each row, okay, for each row of your file, we are gonna get the row dot length. Okay, so this is the function we are going to use. Okay, so now if you click on this and press alt plus, it will say it's the RDD of int. So what you get is the length of each and every row of your file. So I'll just open this data set and show you how it looks. Okay, so this is my sales data. So what it has is it just has some um, the sale of different countries. So it has a transaction date, product type, and then price, payment type, name, city, state, country, and all these details. Okay, so what we are going to do is we'll take the length of each and every line of it. Okay, so now if you see, we have got, I mean, if you see your example here, so this line length will get the line length with the help of this function. Okay, row dot length, and then we'll just print it. And printing of RDD is you give the RDD and it has a method for each. So for each row in your RDD we want to print. Okay, so each row of the RDD we want to just print. Okay, so yeah, that's it. So this would just print here. What we'll do, we'll just give a sleep to check our program in Spark UI. Okay, so we'll just do it for this program. From next example, I'll just show you the code here in the IntelliJ itself, and we'll run it. Okay, so so this is our program. It will read this file, traverse through each and every row, and get the length of each and every row. Okay, so let's just run it. Okay, right click on it and say run map transformation. It will show you the results here. Okay, so I'll just maximize it. So this logs I was talking about, if you don't put it in error mode, so this is your Spark UI. Okay, so this is the length. So we have 20 lines. So it is printing the length. It is not coming out because I've given a thread, because I wanted to go and check the Spark UI. Okay, so this is my Spark UI which it has opened, and as you see, it is performing this action here. It has created a job with one stage and one task. This is the DAG created. Okay, so what DAG is doing is, see, it is just reading the file and then it's applying the transformation on it. Okay, and we'll check the detail of this in probably next video. I just want to show you how this task looks, and it will wait for some time and then come out. So what we get, the result is length of every line from our sample file. Okay, yeah, this is our sample file. Okay, so as you see, I have just put my cursor here. It shows 118. Okay, sorry, so this shows 118. So this is nothing but the length of line, and this is what we are getting. Next is, no, this is 118. This is your header. Okay, second line is 117, and then third one is 106. Yeah, 106, because it doesn't consider the last new line character. Okay, fine guys, and it starts. Okay, so this was about your map operation. In next one we'll take the flat map. Okay. Okay guys, so the next program is for the flat map. So I already have the code written here. So it's exactly similar to the previous map code, The only difference is instead of using a map, I'm using the flat map. And what happens is in flat map, it flattens the output. So what that means is when we apply the map function, it implements that particular logic on every row, and when we apply flat map, it applies the uh, the transformation on each row and flattens the output. So in this case, if you say for map example, we were calculating the line of every row. Flat map operations is useful when you want to perform some action on each and every field. Okay, so suppose in our sales file, okay, this is our sales data. So in case we want to count the do the word count program. Okay, so every word, okay, every word, so comma separated field is a word here, right? So every word would be considered here, so you can perform any operation on every word, but in case of map it was on every line. Okay, so let's just check this. So what I'm doing here is I'm reading every line, or I'm traversing through every line of my file. So I'm reading the sales file, traversing to every line of my file and splitting that file with the comma. So what it will do is it will give me the words, all the words which are separated by the comma. Okay, so let's run this program, and after that I'm just getting this. So this is your RDD of string type, so it will have the list of all the words, and then we are just printing it. Okay guys, so let me just run this program. Say run flat transformation. Okay, let me maximize this. Okay, so now you see here, okay, yeah, so this is our header and it has flattened every line. Flattened means it is divided all the lines or split it into tokens. Tokens are nothing but your field, and it is just printing it in a new line. So this comes handy when we perform word count operation, or we want to perform any kind of operation which is on every word. Okay, okay guys, so this was about flat map. Next one is the filter. Okay, so we'll take up an example for the filter. So filter is used when you want to select some of the records from the file which is satisfying the condition you have mentioned. Okay, so let me just show you that. Okay guys, so in this is the filter program. So it is the same program. What I'm doing is I'm just changing the transformation which we want to implement, so that you would be able, it would be easy for you to even relate it. Okay, so what I'm doing here is I'm just reading the same sales file, okay, with 20 records. So what I'm doing this is, we could have done it with some sample data as well, but if you do it with some real data, it would give you the real exposure, because when it comes to the Spark, this kind of data we ultimately process, right, to satisfy some of the real-time problems. So this is the sales data. So you can take it as a data from probably any of the online portal like Amazon. So they want to check that, okay, from my today's sale, you may have probably millions of record in a file, okay, for a day. So what they're trying to do is they want to check then how many users have used MasterCard for the transaction. Okay, so how many sale record has the MasterCard in it. So what we are doing here is we are reading the file, same as our previous examples, okay, which is giving us the RDD of records, and then on this RDD we are applying the filter transformation, and it says for every record you apply the transformation. This function contains, so contains is the available function for this for every row, and we are giving the condition here that it should have MasterCard. So it would filter out all the rows which has MasterCard in it. So if you go to the sales data, okay, it shows us this is the MasterCard. Okay, so all these records, wherever we have MasterCard as the payment type, yeah, I think it's payment type, price, and yeah, so payment type is MasterCard, it would just filter out all those records. Okay, so let's just run this program and see. Right click on it, say run filter transformation. Okay, and ultimately we are printing all this. So MasterCard is a RDD, and we are using, with the help of for each, we are printing. Yeah, so as you see, it has filtered out all the records from the file which has MasterCard. Okay, guys. So the next transformation is mapPartition. Okay, so let me just take out the program. We'll just check the definition of it. It says similar to map, but it runs separately on each partition. Yeah, so yeah, guys, I think if even if we create a program of it, yeah, I think I can show you the program, but the only difference is it won't show you any difference as such in the output here in like on your IntelliJ or IDE, or when it generates the output. But where you get the benefit is when you run it on the cluster and when you run it on the partition. So suppose you process a file with some 5 million records, and which on which you have maybe 50 partitions. So it would run that map task or the map transformation. It would apply the map transformation on all the 50 partitions in parallel, right? So we get the performance benefit here. So the output would be similar to map. The only benefit we get is the performance benefit here. Okay, and it says the function must be of type iterator, and when running on a RDD of a type T. So iterator is nothing but because it runs on a partition. So if you have suppose 50 records with 5 partition, so every partition will have 10 records. So it would give you the iterator which with the help of which you can traverse in each partition. So first iterator will have 1 to 10, second iterator will have 11 to 20, and so on and so forth. Okay, so let's look at the example of it. I'll create a example using probably a small sample data here. Okay, so let me just quickly take out the program. Yeah, guys, so this is the program for mapPartition. So what I'm doing here is I'm not using the file, because reason being, if I use a file, it would be difficult to show you the partitions there, right? So I'm using a sequence. So this, what I'm doing is I'm creating a Spark context. Probably you can just Google it. It's a simple thing. I'll just explain you. So what it does, it with the help of Spark context, we parallelize it, and parallelize method takes a sequence. So this is the input, and you can mention the number of partitions here. Okay, so we are going to process the data, so it will generate the number from 1 to 30, and we are going to create 3 partitions out of it. So 1 to 30, when you slice it by 3, will have 10 records in all the 3 partitions. Okay, and this will be the list. Yeah, so what it does, it when you perform a parallelize operation, it will create 3 partition, and you'll have a, as I just mentioned, it will have a iterator. So this iterator would be for the every partition, right? So what we are doing is we are just trying to get the first with the help of x dot next. So this is for every row or every partition. Yeah, so we'll have a list of elements, and we are trying to get the first element of all the partition. Okay, and this is some of the conversion we are supposed to follow while printing it, because this is not your RDD, this is the array of int, because array of int, because it will have your numbers here. Okay, I'm also giving this without partition, and I mean using the same logic here, but one is with partition and one is without partition. So this is just to show you that if, even though you are applying mapPartition, but if you do not have partition in your data, so either it partitions the data set would be partitioned based on your Hadoop file format, block size, it would split your data, or else we are supposed to manually mention it, or so we can mention 3 partition, but here we are not doing it, so it will just have a single partition. And when you run this map function, it would not make any difference here because it's a single partition. But here it would have 3 partitions, so it will process the data in 3 different partitions. It would be much faster compared to this. Okay, so we won't be able to see much difference in the performance here because the data set is very small, but definitely when you perform this kind of operation on huge data, it would show you the huge difference in the latency of your results. Fine guys, so let me just execute this. So what will, yeah, and another thing is just Spark, or when you run a Spark job on partitions, for every partition there is a separate task created. So here we'll have 3 tasks created, and all the 3 tasks will run in parallel in 3 different executors, and it would give you the faster results. Whereas in this, as we do not have partition, it would just create a single task and it would be executed in the single executor. So single executor would process all the 30 numbers, and in this every executor will process 10 numbers. Okay, so that was just for your information. Let me just execute this program. I've given little longer time for sleep here because I wanted to show you the number of tasks created here in the Spark UI. Okay, so let's just execute this program. Okay, so it started. So what we'll get the result is okay, this is our Spark UI. Let me just get it here quickly. Okay, yeah, so okay, yeah, so as I just mentioned that when you have a task with partition, the Spark job with the partition, it would be created, it would create 3 tasks for it, which you see here. And when you have a single partition, it creates, we have 2 different jobs created because we have 2 different actions here, right? This is one and this is another one. Okay, we are doing the collect action here. Okay, we'll go into the detail of actions as well. For now, just take it as it is, and our result is the first element of every partition. So 1 to 10, then 11 to 20, and 21 to 30. But the next one is the output of this, which doesn't have partition, and it has just the first element as 1 because 1 to 30, all the 30 numbers are in a single partition. Okay, so let's check the Spark UI, guys, what it shows. So we'll click on this. Okay, and we'll okay, let's go back. We'll try to open it in different tabs to check the difference. When you go here and see, okay, it has 3 executors, right? So okay, it is executed, yeah, it is executed in driver because we are running it in the local mode. If you run it in the cluster, you would see 3 different executors here. Suppose you're running it in the 3-node cluster, you will see that all the 3 partition would be executed in 3 different executors, but it is a local mode, so we are seeing this. Okay, and in this case we just have a single task created. Okay, so when you run 3, okay, so I think this our program has come out. Okay, yeah, so it has come out. That's the reason our Spark UI is gone. So yeah, I think you've got an idea what I meant here by putting the partition. Okay guys, so this was about mapPartition. Okay, so I think, yeah, that's it for this video. In next video, I'm going to show you some more transformations which would be very useful when you are solving any real-time problems with the help of Spark. So by doing this with the real-time data like our sales file, we get a good idea, the kind of problems we are going to face when we are solving the actual problems. Okay guys, so yeah, that's it. Thank you so much for watching this video, and in case you like it, please hit the like button, and also you can put your comments in case you have some suggestions for it. I know my videos are a little longer, but it's just for for your better understanding. Yeah, so probably you can speed it up a bit if you want to watch this video quickly, but I think if you understand this, it's gonna really help you. Okay guys, so yeah, for now I think, yeah, that's it. Okay, thank you so much. Bye bye.